What's happened to Taban? Did you meet him? Taban?
I don't know if he's coming.
Yeah, I know he's not coming, but how he is doing at school? Did you meet him? Everything is okay?
I think he's fine.
Okay. All right, guys. So last class, we wind up the lesson with the point of intersection. And then, so I show you how we can able to find a point of intersection, and then there's a do try moment. So there are a few questions we need to going back to learn how to mark the point of intersection, and then it's come to exercise. So, and then there's going to be a unit review, unit 5 review that's talking about everything that on linear relations, and then moving back to unit 6. So we want to going back to that. Before that, I just needed going back to the homework questions. So how many of you did the homework questions? Yeah, let me find out who is coming in. So this is done. That is Nishal. Did you guys do the linear relation homework questions? Okay, anyhow, I'm gonna get started. I need to move on. So we're gonna moving back to some couple more questions about finding that point of intersection. So let's going back to this example. So we want to find a point of intersection for y is equal to 2x plus 3 and 3x plus 2. So let's going back to Nishal. Nishal, how are you, Nishal?
I'm good.
So what did you find out as your answer and the homework for this example?
Which page is this?
I didn't impose that. You need to access the OneNote. Okay, guys. So we're gonna moving back. So my example. So first step, the slope. So can you tell me what's the slope of this line? What
2x.
is the slope? What?
2x.
So 2x is the slope of the line. Okay, I'm gonna go back to Shreya. What is the slope of the line, Shreya?
2.
Sorry?
2.
2. You don't tell the slope with the x. Okay, what is the y-intercept, Shreya?
3.
3. All right, now going back to Vishali online. What is the slope, Vishali?
What's the slope?
For the second line.
3.
3. And then the y-intercept is?
Are you asking me?
Yes, I'm asking you.
2.
Okay, and then Adi, can you open the door? My next student is here. My next student is here. Can you open the door for her? Okay, just let the door open and she'll be coming. Okay, but when she come in, please close it, okay? I tell him to close it too. Okay, so now what we're gonna do is, can you do that question, sir? Find a point of intersection. So we learned how to find a point of intersection. So I know that you guys didn't do those questions. I'm gonna show you, recall what we have to do. First, we're gonna mark the y-intercept, and then from y-intercept, we're gonna go back to the slope. So to find another point, slope 2 mean is rise over 1. So rise is 2, run is 1. So we're gonna go 2 unit up, 1 unit to the right. So what will happen if I 2 unit 1 run up? I can simply mark the line based on the pattern. So if I'm gonna mark the line, hello, how are you? So if I'm gonna mark the line based on the pattern, what you're learning at school?
We're finding out the test on graphing in a
Okay, how was that?
So far good. We did a mock test.
You got it back?
Yeah.
How did you do? It's a test or quiz?
It was
Hold.
like the mock test, like what would be on the test.
Oh, so when is your actual test? Okay, I think that you might be able to catch up on things that I'm gonna go through. Then I'm gonna mark, if you guys didn't understand, you can tell me. So then I'm gonna mark that y-intercept, which is 2. So we're gonna mark the y-intercept, which is 2. Then to roll the slope, 3 over 1 is rise over run. So when I'm gonna do 3 over 1, we're gonna go 3 unit, 1, 2, 3 unit, and then run 1 unit. So you can see my line is going to be goes like that. Now, based on the graph, Nishal, can you tell me the point of intersection? What is the coordinate of point of intersection based on the graph?
1, 5.
That's right, 1,5. So that is how to find the point of intersection. Pretty good. All right. Now we can able to verify this makes sense. So how to verify? Let's go back to line 1. Line 1, we got y is equal to 2 times, this is x is 1 plus 5. So if I do that, I mean plus 3. So if I do that, 2 plus 3 is 5. You know, that is my y, isn't it? So let's verify that point is correct point. And then if I go back to line 2, how do I verify? Y is equal to 3 times 1 plus 2. So that is 3 plus 2, which is 5. That makes sense. That point of intersection is correct, isn't it? Okay. So you guys got a question to find out the point of intersection. So what I want you guys to do, you guys gonna do it now. My folks, you can graph that on Desmos, and then can you guys find out the point of intersection? Draw that on a Desmos graph and find the point of intersection.
Wait, follow question.
Yes, sir.
When it says 1/2, you just change it.
Right?
When it says 1/2, you just change it.
1/2.
0.5.
Well, I'm not going to teach you, sir. We did that last class. Just find the point of intersection. And there's something that I think I should be able to see what you guys doing it to make sure that I can see your work in lifetime. Just give me a moment, guys. Give me a moment. Desmos teacher. I think that I have a smarter way to execute things, custom activities. And then this is going to be MTH, another math, and okay, pretty cool. Create this activity. And then I'm going to be at my couple of slides. So let's add 10 slides. And then all I'm going to do the first slides, I'm just going to say note. So I'm going to call slide 1. Please show your steps. All questions in the space below. That's okay, it doesn't label it, that's okay. So what I needed, I got a multiple slides, that's fine. Now I need a graph in area. Okay, pretty good. All right, so now let's preview how that looked like. And then you guys can keep on doing things on the same place. I don't need the slides. The slides, okay, pretty cool. All right, Math Emperor. And then November 4th lesson. We can't really let these guys fool around, right? So what I'm gonna do, assign. All right. All right, guys, go back to your Google Classroom, my dudes on the other sides. Go to your Google Classroom and access the Desmos template I pasted. So you guys should be able to access the Desmos. This is going to be Teachman Man Emperor. And this is basically, I'm just gonna say edits. I'm gonna be put this, check your understanding, class practice. Okay. So did you guys access the Desmos task?
Yeah.
Yes.
Pretty cool. Let me go back one more time. Desmos teacher. And this was classroom activities, pretty cool. And then I'm gonna sign in, log in into Google, logging in my new account. All right, so now I need to go back to dashboards history. So my dashboards is today, dashboards. Oh yeah, this is pretty cool. So all I want you guys to do, on the first slide, you guys going to do this question. I want you guys to graph it and find the point of intersection answers on there. So you guys going to do that in there. And I can see your work. And then are you guys done? Yes, using a calculator as a phone? Are you done, sir? Let me see the graph. What do you think? Every work I asked you to do, you can type your response there. You can enter your equation on the graph. You can enter the equation on the graph. So graph is allow you to enter your equation. First, you're going to make that mean now type the equation and tell me what's the slope and the y-intercept. Vishali, can you access it?
Yes. Do you want us to draw on the graph or?
So you're going to be first on the space provided to type your answer. You're going to type the slope and y-intercept for those lines.
Okay.
Then on the graph, you can graph it. So in other way, if I show you how exactly it will look like on my side and Desmos. So if I'm going to go back to this task here. Oh no, I think that you can really, I made a mistake on that task. You can really draw it. That's okay. How about you guys type the response for that question? You do the graph on your side and then show me the answer.
Okay.
Okay. You can draw the graph and then you can type what you get. So make sure you type what you get for the slope and the y-intercept there. And then you can keep on entering to go back to the next question so I can see your work. Yes, sir. Pretty good. Done. Graph done. Yes, sir.
So we graph it ourselves and then we just type
And
the
then
answer?
just tell me the point of intersection. Yes, sir. That's right. You got it. That's a point of intersection.
But it's zero. How?
You don't know how to do that, sir. Let me see what she's doing. Can you grab a ruler? You need a ruler. Grab a ruler. Okay, perfect. You done? Can you pass the work? Which school you in? Oh, so that's, I always send with Barrows and you and Bill Howard, right? Okay. And then what is the point of intersection? You didn't mark it.
I did.
Where? There are 4 checks. Vishali, did you start to type in your work there?
I didn't type it yet.
You had to type it there. Everything you did, I want to type. Okay, so I see Shreya, line 1. Pretty good. Okay, you got that right. Pretty good. Okay, intersection, you're graphing it. Let me see. Sharon. What are you doing, Sharon? You raised your work?
Yeah. No, I just put in the equations there, not the answer.
Nishal, how about the answers for the questions? Slope and y-intercept. Who's going to do that? So in this page, you guys going to be keep on typing everything for today. Don't raise. I want to see all your work. If you see -2, -4, I can't really see any steps. Where is your slope? Where is your y-intercept for line 1? Where's your slope and y-intercept for the line 2? Who's going to do that? Michelle?
Yeah,
Who's going to do that? I
I'm
want-
doing it.
Just write it down the answer. Slope, y-intercept.
Okay.
So Shreya, you're working on the intersection?
Yeah.
Okay.
I'm confused on doing the slope with the fraction.
Who's that?
Visali.
So you're confused with slope with the fraction? How to do the slope? Okay. Okay, let me take that up. You try. Slope is going to be 1/2. There's no question on that. Y-intercept is -3. Slope is going to be -1. Y-intercept is -6. Any question on that?
No.
Okay. Now, 1/2 means rise over run. 1/2 means rise over run. So what we're going to do, we're going to mark the y-intercept first. We're going to mark -3 first. Then I need to go 1 unit up, 2 unit to the right, 1 unit up, 2 unit to the right, 1 unit up, 2 unit to the right. Did you see that? Hello?
Yes.
So I can simply connect the line. Any question on the line?
Oh.
The next
No.
line is, we're going to start with -6. Slope is 1 unit up, 1 unit to the left, 1 unit up, 1 unit to the left. And you can see that when I do that, I actually get the point of intersection pretty cool. So what is the point of intersection? -2 comma. Therefore, point of intersection is -2 comma -4. Are you guys following that? Now let's check it. Y is equal to line 1, 1/2 x is -2 -3. 1/2 times -2 -1 -3 is -4, isn't it? Are you guys following that? So did you do the check? Did you write it down the check? All right. So now we're going to going back to solving a system linear equation using graphing technology. So you should be able to do the graphing technology to find a point of intersection. So to do that, we can go back to Desmos. I need to type the equation 3y minus x is -3. So let's go back to Desmos graph. I need to know the equation. What's the first equation? 3y minus equal to negative. All right. What is the next equation?
2y equals
4x 4x minus 2. Now you can clearly see the point of intersection. So let's see, Vishali, can you read the point of intersection?
Negative. Is it -1, comma 0?
Other way around, 0,
Oh,
comma.
0, comma -1.
Okay, so we see the point of intersection is going to be 0, comma -1. We can also graph this to verify, but the only problem is to where we graph it. You need to know how to rearrange the formula. Look like y is equal to mx plus b. Let me do that. 3y, if I move the x to the other side, x minus 3. To find a y, I have to divide every single term by 3. So y is equal to 1/3 of x minus 1. So I will mark my slope at 1, -1. So y-intercept -1. Slope is 1/3. So 1/3. So 1/3. And then here. So now I should be able to draw that line like that. So not quite what I want. Then I can just draw the line like that. Make sense?
Mm.
Similarly, we can sketch this. So y is equal to 4 over 2x minus 2 divided by 2. I'm dividing by this 2. So that's give y is equal to 2x minus 1. So how do I do that? Well, I'm going to mark minus 1 first. 2x, rise 2 unit, run to the right. And then obviously we see that what the point of intersection is clearly. Right? So we can also do that by graphing. That's what I prove it. So graphing also, like I just following that picture. All right. Now, let us solve the linear system of equation, for example, by method of comparison. So what that basically means, ensure both the equations are in the form of y is equal to, then compare two equations to set the y is equal to. So what we're going to do this time, when the point of intersection happens, both y value must be equal, isn't it? So what we're going to do, we're going to say half x minus 3 is equal to negative x minus 6. We had to solve for an equation. So Vishali, what do we have to do to solve for the equation? What's the first step? When you see an equation like that to solve for x, what we have to do? Yes, somebody say something. Okay, keep going.
You have to move like the constant to the other side.
That is not the right first step.
Combine all the like terms.
And that is not the right first step. Let's see who can tell me the right first step. Shiron, what do you have to do?
You change the fraction to a decimal.
Nope. Let's go back to Shreya. What do you have to do first step?
You add 1 over 2 with x.
No, we have to get rid of the fraction. That's the first step. So to get rid of the fraction, we got a denominator 2. We got denominator 1, denominator 1, denominator 1. What is the least common multiple for all the denominators? 2. We're going to multiply every single term by 2 first. We're going to multiply every single term by 2 first. So 2 divided by 2 is 1. X minus 6 is negative 2x, negative 6. Now I can follow what you guys have said. It's a two-step equation. So I don't want a 6. So if I get rid of the 6, I need to add 6 both sides. Let's give x is equal to negative 2x. And the negative 6 plus 6 is going to be 0, isn't it? The next step is I'm going to move the 3x, 2x out of the side. If I just going to move the, I just need to double check what's going on here. 2 minus 6. And then you got minus 6 in the other side. That's interesting. So I'm going to multiply by 2 minus 6. Oh, I made a mistake. You guys didn't tell us. It should be 12. That should be 12. So that should be minus 2x minus 12 plus 6, isn't it? Okay. So that's going to be my x is equal to negative 2x minus 12 plus 6 is negative x. Now, in the two-step equation, we can move the x at the other side. So that's became positive 3x is equal to negative 6. From here, x is equal to negative 2, isn't it? Now, I can use the x to find my y value. How do I do that? Y is equal to, that's the second part. Use y is equal to 1/2 of negative 2 minus 3. Negative 4. Are you just following that? Are you just following that what we're doing?
Yeah.
Yeah.
Now check. How do I check it? Let's check a line 1. Y is equal to 1/2 of x is negative 2 minus 3. So negative 1 minus 3, negative 4. And we got that checked. Correct. You also need to do the line 2. Y is equal to minus x. So minus 2 times minus 3. And then minus 6. So that is going to be positive 6 minus 6 is going to be 0, which is not correct. So something went somewhere wrong. Line 2 doesn't give me the right value. So line 2 verification fails. Line 2, y is equal to negative x. And x is negative 2. So negative of negative 2 plus 6, that's minus 6. That's my equation, right? Negative of negative 2 is Positive 2 minus 6 is negative 4. Are you guys following that? Pretty good. All right, now it's you try time. So can you just do this question on Desmos by setting the y is equal? Pretty easy. This is pretty straightforward. Enter, just enter and then move on the Desmos to show me the steps.
Do you want us to write it on the same slide?
Yes, same slide. You guys gonna write the steps on the same slide.
Wait, do you write y equals 40x plus 200 equals 30x plus 1?
So we balance the y, sir. We balance the y. Don't you see? We say these two equal. Then that's became that is equal to that. So what's your question? Okay. Michelle, are you typing the work on the Desmos?
Yeah.
Where are you typing? I only see slope is 1/30. What you're doing with the slope?
Sorry?
This question is not about finding the slopes. I'm not sure. Are you doing this question?
Yeah.
Did you understand how we did this? We balanced the y to create an equation and we solve for it.
Oh, okay.
Where do you get 400, Shreya? You got a 400, but on the formula I only give 200. So what did you mistakenly copy this?
Oh, I copied it wrong.
Okay. Pretty good. Yes. I'm going to show you how to type nicely on the Desmos. For those who are on Desmos, let me show you how to type nicely in a moment. So it will make a beautiful print. So let me show you guys how to type in Desmos. Okay, you guys gonna use this technique. So let's going back. Let's going back to my Desmos task. So I'm just gonna do the preview. So let's show you what you have to do. You see there's a little button called math. If you click on the math button, if you're typing 40x plus 200 equal to 30x plus 1000, it will be making that equation looking cool, beautiful. So that's my first line. So you can see x's are in italic. Then you click in here. So you're gonna show the step 40x. And then you don't want a 200, so you show that you subtracting 200, 30x minus 1000 plus 1000 minus 200. And then you show on the next step. So therefore 40x, you're gonna and then use the math mod. So if you do the math mod, it'll looking good, 40x. And then of course, you're gonna show you that you're gonna subtract 30x on both sides. 30x, which is basically 800 minus 30x. And then go back to the math mod again. So enter, and then that's going to be math mod 10x is equal to 800. And then I'm going to show you, enter my math mod again. So 10x, so you can do something called in the math mod. If you do fraction, FRAC, it will bring the fraction. So 10x, and then you go in here, divided by 10, and then still keep the math mod, and then equal to, if you type fraction, it will bring the fraction mod for you, 800 divided by 10. And then you're going back to the next step. Oops. And then you go back to the next step, again, math mod. So you can say x is equal to 80. Is it a pretty cool? You just go back to the math mod. It's allowed you to type in a math mod. And then I can see a nice workout you have been going there. Are you seeing that? How do I type it?
Yes.
Okay, I want you guys to use the math mod for each line. So now we got x is equal to 80. So then how do I get my y is equal to? So I'm going to go back to my math mod to find a y. So y is equal to, going back to 40 times, x is equal to 80, right? And then plus 200. So going back to the math mod, therefore, going back to the math mod, y is equal to 8,200 plus 200, isn't it? Does everyone get the answer? 3,400?
Yeah.
Yes. So
Yes.
I want to see that. I want to see that math mod, and then this is super cool. This is what I'm gonna do for the rest of the classes. I can see your work, everything on one slide. If I time permit, I will create a multiple slides. So just gonna stick with that. So anyone come online, I can see your work. You can split it. Task 1, task 2, task. Okay. So we are done with that. Now you see all the exercise questions. So this is about exercise question to play around with, playing around with finding the coordinate in the different ways in application. I don't want to spend time on doing that. So the whole exercise is going to be homework due on 12th, 11th. Write it down, sir. The whole homework. Next Monday, it's due. So that's going to be on. Linear relations, partial, graphing, finding point of intersection. Because I need to move on to my today's topic. Are you following that? All right. Today we're going to moving back to this following topic. So what we're going to going back to is. So you got a good exercise to practice. So we're going to move back to transformation of lines. So understand how to change lines on the graph with shifting, rotation, reflection. So let's go back to a simple question here. The graph of y is equal to x shown on the grid. The dotted line y is equal to x has been moved 3 spaces below. So if you can see, if I move this line 3 spaces below, I got the dotted line. Everyone seeing the picture? Is everyone seeing the picture?
Yes.
Yeah.
My question here is, by moving in my equation y is equal to x, what did you guys changing? So let's going back to Nishal. By moving it 3 units down, what might be changed to the original equation? What might have changed to my original equation when I bring that to the dotted line? So Nishal is processing it. Yes, sir. The y changes, unfortunately not correct. Let's go back to Vishali. What has been changes to my line?
Like the x.
Shreya, what has been changed to my line?
The Y.
Sharon, what happened to my line? What has been changed to my line, sir? The dotted line. How the dotted line? What's the difference between the solid line and the dotted line?
The y-intercept.
The y-intercept had changed. Yes. The slope of this line is 1 unit, right? 1 unit up. The slope is 1. The x-intercept is 0. Now, does the slope changes from to the new line? No. What's the new equation we got? Y is equal to slope doesn't change, so it's x. That y-intercept is -3. So what pattern do you see? Y-intercept changes. Are you guys seeing that? Hello?
Yep.
Yes.
Sketch the graph of the line after move 2 space up. So if I'm going to move 2 space up, I'm just going to graph it. So what's going to happen? This y-intercept is just going to move to 2 space up. Rise over run, rise over run, rise over run, slope doesn't change. Rise over run, slope doesn't change. And you can see the only thing is change is going to be the y-intercept. As you see in the picture. So this is happening when you move the graph horizontally upward, vertically up or down. Makes sense? Are you seeing the pictures there? Okay. Now let's go back to the next one. Reflection of a line. The graph of 2x on the grid. The dotted line shown is when it's flipped. So flip means you reflect it over x-axis. So what does that mean, reflect over x-axis? Let me take some coordinates. 0 remains 0. When you reflect this coordinate, 1, 2, on the x-axis, the x coordinate won't change. By y coordinate is going to be became negative. So 1, -2. Did you guys see that? Are you just following that?
Yes.
Let's look at this point. On my original point, -2. When I reflect it on the x-axis, x coordinate doesn't change, y coordinate is going to become 2. Do we have that point? So if you look at the slope of this line, rise over run, so 2, 1. So slope is 2. Y-intercept is 0. They want the dotted line. The slope of the dotted line, you go 2 units up, 1 unit to the right, from 0. So rise over run is going to be rise is 2, run is negative, so -2. What is the y-intercept? So equation is -2x, isn't it? What pattern do you see? What did you notice about the slope? So what's happened to the slope? Original slope is 2, isn't it? When you reflect, the slope became negative, isn't it? So slope switches to its opposite, isn't it? To its opposite from the original line. Are you following the picture? Hello?
Yeah.
Hello? Okay. So we're going to move back. Are you writing, sir? All right. So now we're going to go back to, so what we see first, we say vertically moving. Vertically moving affect my y-intercept. Then we are reflecting on the x-axis. That's affecting my slope. Simply it's negative. The next transformation is going to be rotation of a line. A rotation of that transformation in which the line turn about a point called the center of rotation can be turned either clockwise or counterclockwise. So you have y is equal to 2x because that is rise and this is run. So this is the y is equal to 2x. A pin is put on the graph and the line is rotated 90-degree clockwise. So clock moved this way. So what they did, they simply moved this 90-degree clockwise, 90-degree clockwise. What's the slope? Let's calculate the slope. The dotted line. Rise, -1, run is 2, isn't it? Make sense? Y-intercept, 0. Equation is -1/2 of x. Let's go back to the original one. What is my slope of the original one? 2x, isn't it? So what pattern do you see? When rotating by 90-degree, clockwise, the slope changes. Slope changes to negative reciprocal. Negative reciprocal. What does that mean? Original slope is 2. Can I write 2 as 2 over 1? Why? 2 over 1 is 2. So we can write it. What is negative reciprocal of this is negative. You flip that. For example, if I have a 2 over 3, the negative reciprocal of that is going to be Shreya. Can you tell me what is the negative reciprocal of that is going to be?
-3/2.
Pretty good. -3/2. So let's go back to Nishal. If the slope of a line is -1, what is the negative reciprocal of that is going to be, Nishal?
-1/1.
Unfortunately, it's not right. So I'm going to show you -1 can be written as -101. If I flip it, I need to put the negative sign. So let's see, this goes up, this come down. -1 divided by -1 is positive 1. Are you following that? Okay. Let's give you slope is -2 over 6. So Vishali in person, what is the negative reciprocal of that? Six over 2, that's right, negative, because that will negative will change the negative positive. Is going to be clear. Are you guys following that?
Yes.
All right, guys, are you guys following that? Okay, so we're gonna go back to a little exercise. Starting with the line y is equal to x, graph the line whose transformation or reflection on the x-axis. So I'm gonna draw my first line. I is equal to x. Reflection on the x-axis. When I reflect on the x-axis, we talk about it. What is going to happen for the reflection on the x-axis? Every point will be switched. So slope became negative. So negative of x, isn't it? I just seen the first step. What's happened to my graph?
Yeah.
Just give me a moment. I just need to send my recording. That should be go live. I started record. Okay, so let's send it to one of my students. Okay, that's what she's supposed to watch it. Hopefully she can see this. So I need to share this link. Copy the link. Okay, pretty good. Done. All right, so where we are. Oh, yes. Now translate 2 unit up. So if I translate 2 unit up, slope won't change. So this every point is going to move 2 unit up. Every points are going to move to 2 unit up. Every points are going to move to 2 unit up. Every points are going to move to 2 unit up. So how that's going to look like? You can see that's going to be my line, isn't it? Everyone see the picture?
Yeah.
So what is the knee equation? So Nishal, can you tell me the knee equation of this line?
What was the question again?
Can you tell me the knee equation of the line? I put an arrow mark. Akshara, not Akshara. Shreya.
X plus 1.
Unfortunately not. The slope of this line is negative this time. How do you see? You see that y-intercept this case, and that we talk about when we reflect on the x-axis, slope will change to its negative, isn't it? Are you seeing the picture? Yes, no, no, yes. Okay. So this is exercise questions. So we will revisit the exercise question in a moment. So what I want to do is I would like to see if you guys can answer the question. All right. So everyone is going to do it. Translate the graph 2 unit up, find the equation of the knee graph. How is the equation of the graph connected to the equation of the parent graph 2x? So they want you to translate the graph and create a knee equation. So can you guys do that in Desmos, the first exercise? You're going to translate 2 unit up and then write the knee equation. And then what did you notice about those 2 lines? That's something we want to see it on Desmos. Just write it down in the equation if you translate it to unit app. Right? You done? Unfortunately, it's not correct.
Okay, what's wrong?
Hmm?
It's a what's wrong.
No, I can't. We have been doing this, so you should know what exactly you're doing, sir. Let's go back to these guys, what they're typing at. Vishali, where are you doing the work?
I'm kind of confused how I type.
Or
Like,
just type it regularly. Don't worry about the math part.
so I just,
Just type it.
what do I type? Like the new equation?
That's right. Find the equation of the new graph. You're done? Are you done? You're graphing it? Did you graph it, sir? Huh?
You said it was wrong.
The graph. Yeah, that's still wrong. The graph's not right. Welcome to the home. Just coming by. Windows coming in through my mic to confuse them. All right, what is let me check the answers. I completely forgot to check that out. So, Shreya, you got that right. And Nishal didn't get that right. That's okay. Vishali didn't get that right. And then Shiron. Are you typing your work, sir?
Yeah.
Okay. So guys, we talk about it. If you translate to unit up, the only thing is going to happen, the y-intercept. So currently the y-intercept is 0. So therefore the y-intercept is going to be 2x plus 2. How is the equation of the graph connected to the graph of the parent graph? So let me use y is equal to 2x. So this is 2 unit up, 1 unit right, 2 unit up, 1 unit, 2 unit, 1 unit right. So this is going to be my graph, isn't it? Now let me draw the one that translated. I push it 2 unit up, so it's gonna go here. It's gonna be every point's gonna move 2 unit up. Every units are gonna move 2 unit up. If I do that, this is going to be my line, isn't it? What do you guys notice about the relationship between that black curve and the red curve, Vishali online? What do you see about the graph? How do they look like?
I don't know.
Sharon, how they look like?
It has the same slope, just different intercept.
Shreya, how they look like? In terms of geometry.
Parallel.
Parallel. That's right. That's the right observation. They are parallel. Why they are parallel? They both have the same slope. Did you guys see that? Do we have the same slope? So when we have the same slope for two linear relations, they're going to be parallel. Are you guys following that? All
Yeah.
right. So now going back to specific questions. All right. I really want to going back to. All right. I really want to go back to my parallel and perpendicular lines. Can I have a handout, sir? Actually, I don't need a handout. I just gonna go back to, if I talk about a parallel and perpendicular line, then I linear versus nonlinear relations, and then there's an exercise here. Graphing standard form and reciprocal relation. And then region defined by area, that's going to be inequalities. Okay. I'm gonna move back. So we talk about the transformations. So what we want to talk about it next is we want to going back to some important factor about these lines. So the exercise is due. You know when it's due again next class. So when you come back next class, now just one page. 12, 11. 12, 11. 12, 11, 2024. You guys get to do the transformation chart. So I need to moving back to talking about time permit. I'm going to revisit. We're going to come back to parallel and perpendicular lines. So we want to observe a few things about two lines are parallel. We already talk about if two lines are parallel, the slope must be equal, isn't it? So let's going back to that question here. What is the relationship between line and one, line two? We know they are parallel. Are you seeing that?
Yeah.
Right. All right. I'm going to let you guys to find the equation of both lines. Can you guys type the equation on line one and line two on the decimals, please? Equation of line one and line two. Let me see, how would you type the equation? The equation of line one and line two and decimals. Find the equation of line one and line two and decimals. We done? All right. Line one, line, unfortunately not. Sorry, man. You have a bad day. That's okay. I know what the bad day is. Because your friend didn't come to school. Something you need to send it to her. All right, so let's see how they are doing. All right, so these guys, I think that these guys doesn't know how to use the decimals part. I'm gonna check it out what they have doing. So line one, pretty good, sir. Okay, you got it right. So let me going back to Shreya. Line one. Are you raising your previous responses? That's okay. That's okay. That's okay. That's okay. And Nishal, you still writing the equation, I believe. Okay, can I see your work, lady? Let's see what you have. Pretty good. All right. So some of you got it right, guys. This one, you see that is going through the origin. So how do I find the rise? Choose 1 point, go up 1 unit up, 1 unit to the right, isn't it? So line 1 has a slope 1. So this is x. If you go to line 2, let me choose 3. If I choose y-intercept is 3, and then to go to this point, 1 unit up, 1 unit to the right, rise over 1. So it's going to be x plus 3. Are you guys following that? What is similar between the equation? They have the same slope. But they're different. Y-intercept, isn't it? Are you guys following that? We say 2 lines are parallel. They have the same slope, but different y-intercept. They never touch. So consider the following pair of lines. Do you think those 2 lines are parallel? Vishali, do you think they are parallel? Why?
Yeah.
Okay, Vishali, both Vishali say yes. So online. Okay, let me go back to the online Vishali. Do you think they are parallel?
Yes.
Why?
Because their slope is the same.
How do you know the slope is the same?
Because I checked it.
Where do you check it?
Sorry, I'm confused.
I'm purposely making you confused. So what is the slope of the first line? What is the slope of the line?
I thought you were talking about the other question.
No, I'm talking about example 1.
Oh, 2 over 6. No,
2 over
sorry.
6. Come on.
2.
What's the slope of the next line?
6 over 3.
How much is that?
Sorry?
How much is that? 6 over 3.
Like reduced?
Yes.
2 over 1.
That is 2, isn't it? Do we
Yeah.
have the same slope? So
Yes.
can we say these 2 lines are parallel?
Yes.
Make sense? All right, so let's going back. What? What? I just say 60 divided by 3, which is 2. So both lines have the same. Okay, Vishali in person. Are these 2 lines are parallel? Why not? Yeah, so I got slope 3, slope of -3. Slopes are not the same, isn't it? Slopes are not the same. Therefore, they are not parallel. Are you guys following that? Make sense?
Mhm.
All right, so now we're gonna go and make example. So what we're gonna do is we're gonna going back to finding the equation of the lines when some information is provided. Determine equation of the line that is parallel to y is equal to 3x plus 5 and passes through the point 1, 1. So we want to find a new line. Nishal, what is the slope of the new line will be?
Could you repeat the question again?
Where were you when I asked the question?
I heard something about slope, but I wasn't able to hear the full question.
Okay, can you hear me my question? Let me ask.
Yeah.
Okay, I'm not sure, lady. So I asked, what is the slope of the new line?
I'm confused.
Let's going back to Shreya. What is the slope of the new line will be?
3x plus 1.
No, I only asked what is the slope of the new line be?
Oh,
I didn't ask anything. Pretty straightforward. What will be the slope of the new line be? When I ask that question, slope, there shouldn't be x, there shouldn't be y, there shouldn't be no ana in there. It's simply the number I am looking for. What is the slope of the new line be?
3.
3. Because they are parallel. Determine the equation of the line that is parallel. So write out the equation of the line with the same slope, but b as a y-intercept. So we will write y is equal to 3x plus b. Adi, can you stop? Adi, can you stop jumping over? I'm shouting out to my son. Now, we want to find a b, isn't it? We want to find a b. To find a b, they said, there is a point 1, 1 on the line. What does that basically mean? The line y is equal to 3x plus b contain the line 1, 1. Remember, we did some check before. What does that mean? X is 1, y is also 1. So what we're going to do, y should be 1 when x is 1. 3 times 1 plus b. We can solve for the b. 1 minus 3 is -2. So we find b is equal to -2 here. So therefore, the equation of the line is going to be 3x minus 2. Are you guys following that?
Yes.
Okay, can you guys do the next question on? Nishal, are you following that, or you need me to explain that again?
I'm kind of confused with getting B. Could you repeat it again?
Yeah, so to find, did you learn linear relation at school?
Yeah, but I don't think so. We've learned how to do B.
So what's going to happen, Nishal? Every linear equation is the form of mx plus b. So can you tell me what does m stand for?
The slope,
What does b stand for?
the y-intercept.
So whenever the teacher asks to find an equation on the line, your mind always need to ask, is there any way I can find my slope? Is there any way I can find that b? In our previous lessons, we find a slope using 2 points or using a graph. But here we're going to be going back to some other way to find the slope. In this type of question, we are talking about 2 lines are parallel. What do you know about 2 lines are parallel about their slope? What do you know about 2 lines if they have this, if they are parallel?
I don't get the question you're asking.
So my question is, if two, do you see these 2 lines?
Yeah.
What did you notice about the line? What did you notice about the line? What did you notice about those lines? Nishal, what did you notice about those 2 lines?
They're parallel.
They are parallel. What do we tell when 2 lines are parallel? What relationship we explore when 2 lines are parallel?
They have the same slope.
Okay, now I'm asking the same question. If a line, we want to find it parallel, what do you know about them? The answer is supposed to be they must have the same slope. So what they're saying is you have a line 3x plus y, but they're talking about another line that is parallel to the same line. When they say it's parallel to the same line, we know its slope must be the same. Any question on that? We also just learned a few seconds before, their y-intercept are not going to be the same. So we don't know the y-intercept. What we want to do is we want to find the y-intercept. So using the additional information. The additional information given to us, the line, the new line, not this line, not this line, this line, going through the point 1, 1. When they say going through mean, it has a coordinate 1, 1. In other way, on the equation, when x is 1, y is 1. So we're going to be substitute that. Right? Are you just following that? So that's gives me the solution for b, which is -2. So we solve for b. So complete equation, y is equal to 3x minus 2. Has everyone got the question?
Yep.
Yes.
Can you guys do the next question for me on the Desmos? Show all the steps. Vishali, did you get the question?
Yes.
Okay. Can you guys do the next question on Desmos? Don't raise your previous work. Please keep your previous work, guys.
1 second.
What's up?
Oh, no. Yeah?
You have a question?
No, sorry.
Done, sir?
Can you say what's wrong, please?
Your Y intercept is not correct. Okay, let me check these guys. Vishali is away. I didn't see how she's even doing it. So this is Sharon. Let's see, Sharon is doing something. I'm moving your work. Okay. So Sharon, where are you, sir? Are you working on this question or you away?
Yeah, it's at the bottom.
The bottom? I see.
Yeah, it's at the bottom of the page.
Bottom of the page?
Yeah,
Where?
on the decimals.
I also see line 1, line 2. Why?
It's under that.
Okay, I might need a refresh. Okay. What is the final equation, man?
Oh, sorry.
I think I did a mistake in my equation.
What mistake you made? It. Tell me what's your mistake.
I think it might have been multiplying the 0.
Okay, what's wrong with that? Huh?
I just have like the gut feeling that it might be wrong.
Why do you think it's wrong?
It doesn't look right.
You know, it's called math trauma. What you're thinking is the math trauma or just fear of math. Oh yeah, I may be doing it incorrect. It's like, I don't want to drive because I might get into an accident. I don't want to fly because the flight might fall down. That's exactly what you're going through. Your B is correct. That's right. All right, so let's going back to Shreya. Yes, so pretty straightforward. Slope is 4, isn't it? Now going through the B, we substitute the point. 0 is equal to 4 times 0 plus B. So B is equal to 0. Therefore, Y is equal to 4x. Are you guys following that?
Yes.
Yeah.
All right. Now we're going to move back to, guys, perpendicular line. So let's see how that looks like. The reciprocal of a fraction is that when the number and denominator switch. For example, reciprocal of 3 over 5 is 5 over 3. The negative reciprocal is you switch it, but you also switch the sign. Two lines are perpendicular when they meet at a right angle. That is what we call perpendicular line. Now, the key is their slopes are negative reciprocal of each. Negative reciprocal. So, the following lines are perpendicular. As you can see, write the equation for line 3. So, line 3 has, you can see a negative, line 3 has a slope of, if I can go back, line 3, rise 3 units. So, line 3 slope is going to be, so slope of line 3, you rise 3 unit, run to the left, so -2. The slope of line 2, slope of line 4, if I see that, I can go back, rise over run. So if I go back here, I rise 2 unit, run 3 unit, so rise over run. So right is 2 unit, run is 3 unit, so I should put the label here. Now, if you can't see the relationship, if you take this, yes. Yeah, I can show you graph inequality. I have time, so I'll go through that graph inequality in a moment. and then it 3, -2. So compare the slopes. What do we see about the slopes? So slopes are negative reciprocal each, isn't it? Did you guys see that? So compare the slopes. So slopes are negative reciprocal of each. Are you guys following that?
Yes.
How much would have to rotate the line for about the origin to the line? 390 degrees, isn't it? You guys see that? If I move this line 93 clockwise, counterclockwise. What would happen if that rotated by 180 degree? You will get the same line back, isn't it?
Yeah.
Line 4 will align with line 3 again. Are you guys following that?
Mhm.
You have a
Yes.
device? Did you bring a device? That means you bring it at that, you can charge it easily. So come over here. What laptop you have? And then what charger you have on the ball? Don't worry, I have it. So I will come over here, take it, log in. Did you bring your device? Take it out. So before we move on, as Vishali asked about here, teach inequality. So I'm gonna go back to inequality. Inequality is part of this. Inequality is actually part of this. It's actually part of the lesson. So which is coming here. So what I want to do is to teach the inequality following. Okay, to teach the inequality, we want to going back to this little activity. So you're charging it. You're going to be going back to the activity. So I'm going to be, and we're going to going back to Desmos and Desmos activity. So, oh yeah, all right. My password, just give me a moment, sir. Just give me a moment. All right. You will get the inequality. All right. Here we go. Assign your class. Math and Power. All right, can you guys begin the task? We'll post on the Google Classroom. And then you need my Wi-Fi password, sir. I'm just gonna go back to get the Wi-Fi password. So the Wi-Fi password is, the name is going to be Abhi Anandi. Did you find Abhi Anandi? Password is Adi and Avanti 3.14 at. Start the activity. Oh, you just connected my Wi-Fi. Okay. You connected. Okay. Are you guys get into the task?
Yeah.
All right. Let's going back to my dashboard history. So dashboard history. All right. Pretty good. We're gonna look on this task. All right. You gonna connect it, sir? Okay, I'm gonna go back to my task. So I'm just gonna say teach. No response. Get. Okay. This question, you're not being asked to solve this equation. Which inequality correspond? All right. So which number concept might support this complex concept? What represented tool strategies might have learned? You are working on, you can skip that. You don't need to do that. So on the first number line, place many points on the lines are less than 3. On the second number line, place many points on the number line that are greater than -1. Are you just working on the task? Okay. You can use the dots. So you can actually use the dot. You can mark it, use your pen. On the first number line, place many dots on the number line that are less than 3. On the second number line, place many points on the number line that are greater than -1. So let's see how many of you have done it. So I only say Nishal, Vishali, and Shiron is there. I'm not sure what's going on with the other folks. You done? All right. Are you guys done? All right. So I'm going to be post my task. I'm going to overlay it. So if you really see on the first one, on the first number line, place as many points on the number line less than 3. Isn't it? If you guys see, is that representing a line, a shaded line, or it's just representing a single dots? What do you think? Based on how everyone did it. The first response is as a single individual dots, or it's a whole line they're representing?
A whole line?
Whole line, yes, is obviously you can see it, isn't it? And then similarly, if you can see the second one, you see it's a whole line, right? Do you guys see that?
Yeah.
So if I ask you to mark just x is equal to 1, you will only see the dot, isn't it? So why do you think Vishali in person gets a line of points?
Every number in between.
That's right. So there's a lot of numbers there, isn't it? There's a lot of numbers less than 3. 3, for example, 2.9, 2.8, 2.6. So what you guys notice here, when it's come to an inequality, not a single solution, it's so many solutions, isn't it? This is a number line. Does everyone see the picture on the number line?
Yeah.
Hi. Okay, now I'm gonna be unpause it. You guys gonna go back to the next task. So I'm gonna be posted at this point. So I'm gonna be discuss everyone's solution. So this is basically the picture, isn't it? Numbers greater than 3, but greater than or equal to 6. So according to Nishal, number greater than 3. So that means any number greater than 3. But you see there's a little gap between 3 and 4 not being shaded. Then also you see greater than or equal to 6. That means it should be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's not being shaded. Right, Nishal? Do you see visually speaking what you have done is not correct?
Yeah.
Okay, Shreya say the instruction given to place the dots greater than 3 but less than, okay, I posted. Vishali say place the dots anywhere greater than 4. Not quite correct because then I'm missing the dots for 7, 8, 9. Sharon tried to put something fancy. He say anything 4 and then his inequality is not quite correct. Vishali say they are instructed dot number lines which include decimal less than 6.5, then I'm missing -2, -3, -1, 0, isn't it? Are you seeing that? So what instruction might be given to them? You see that it's going from 4 to 5, isn't it? Then there's a little gap on the 5, then going up to midpoint of 6.5, isn't it? So if I want to precisely tell any number is greater than or equal to 4, less than 5, any number greater than 5, less than 6.5, isn't it? Okay, I'm gonna take it out. You guys gonna continue the task.
what does it mean by what inequality might you write for each number line?
Like inequality, x is greater than 5, x is less than 5, x is greater than 10.
Are we doing number 5 or number 6?
You're going to keep going. So, right. So this is, are you guys are not number right yet? Okay, so now I'm just waiting for my response from number 7. So this is, we talk about this at number 7 is something. It's okay. There are four number lines you guys can see. Okay, so I would like to see how they are responded. I don't want to see others' answers. Okay. Turn the Charlottesville. Okay.
Lines on activity.
You don't need to.
Who's a closed circle? Is it like
Include.
equal?
Include. So I'm going to pause this for a moment. So if you guys see on a number line, when they ask to mark x is less than 1 or x is greater than 1, you're not marking 1 point. You're marking so many points, isn't it? So let's going back to something that we're going to be learning. So when I ask to mark on a number line, when I have a number line, so this is my number line 0, 1, 2, 3. If I ask to mark x equal to 4, you just want to be x equal to 4. This is simply going to be just 1 point. On the other hand, if I ask to mark x is less than 4, 0, 1, 2, 3, 4. X is less than 4 is, we are marking this way, isn't it? Did you guys see when we're marking inequality, it is not a single point. It's just the overlapping line, isn't it? Are you seeing that? So what we want to talking about is just an inequality. So here's something I want you guys to, we want to explore. So let's see, I want you guys to create several points. So x plus y, and I want you guys to create x plus y is less than 20. Can you guys tell me a pair of points? I'm going to collect from each one of you. X plus y is less than 20. I would like to collect the pair of points from each one of you. X plus y is less than 20. So let's see what are the points. We can talk about x plus y is less than 20. Let's mark x plus y. So let's start from on line 4. Nishal, can you tell me x and y that will make x plus y is less than 20?
1, 2.
1, 2. Makes sense. And then Sharon?
1, 4.
1, 4. All right. And then Shreya?
1, 6.
Come on, guys. -1, 5. -2, 8. Why don't you tell me the negative number? -3, 9. Did you guys see that? Yes?
Yep.
If I'm going to plot all these points, did you guys think and the coordinate grid? Let me go back to do that. So on a Desmos graph. So we're going to going back to Desmos graph. Okay. So if I want to plot those points, So if I want to plot those points in a coordinate axis, do you guys think this is going to be representing a single line, or it is going to be representing something else? If I want to draw all these dots, if I want to put all these dots in a graph, Vishali, what do you think it will look like? It's going to look like a line or dots. Dots. What kind of dots it might look like? Open dots. So we want all the possible dots that x plus 5 is less than 20, isn't it? Are you seeing that? So if I really going to be draw it, it is going to be really representing an area. It is not a dot. It's going to covering a whole area, isn't it? Because, for example, 1, 2. So 1, 2 is here. Then you guys get 1, 4 is here. Then you get 1, 6 is here. Imagine if I'm going to keep on putting that, it's just going to be an open dot. So what we want to explore it, how that will look like x plus y is less than x plus y. My bad. X plus y. We want to explore inequalities. X plus y is less than 20. So let's going back. Well, I'm going to going back to make this, makes it 5. So that will much better. If you guys see that x plus y is less than 5, you see the shaded region created like that, isn't it? Are you seeing that? Now the question your teacher is going to ask is, they're going to give you a graph, and they're going to ask you to find the equation, right? This is where you guys are going to make it difficult. Now the question is, how do I able to find the equation? So let's see, if this is going to be here, my question, or let's going back to another one, x plus y is x plus, let's say x plus 2y greater than 2. So I'm going to be delete this. Now the question here is, when your teacher say x plus 2y is greater than 2, how do I know this is the shaded region, not the bottom? That's what the question is. So here's what we're going to do. Your teacher definitely going to give a graph, isn't it? Your teacher is going to give a graph. What? Your teacher will give a graph to match it, right? Now the question is, how I'm going to match? There's 2 ways we can think about it. One way, I'm going to be plot, I'm going to pick a random point. You see in my area, I got a 0.5, 5, isn't it? Do we have a 0.5, 5 here? So all I'm going to do is, I'm going to going back to my maths, x plus 2y less than 2. Did I put less than 2? Yes. I mean greater than 2. So x plus 2y is greater than 2. And then I'm going to come back to say what question you have in specific we can discuss. So all I'm going to do is I'm going to put the 0.5, 5. Let's substitute 5. X is 5. 2 times 5. 5 plus 10. What would I get? 15, isn't it? If 15 is greater than 2? Yes. Therefore, that is the graph that's going to match. So let's going back to how to visualize. So this is one of the graph. X plus 2y is greater than 2. We see x plus 2y is less than 2. It's going to be underneath. So what we're going to going back to, we're going to talking about the inequalities, how they will look like in here. So we want to talk about the linear inequalities first. So where is my inequalities? Standard form of reciprocal function. I have my lesson in inequality, but I try to find out which lesson is about linear and nonlinear relations or parallel lines. I think that lesson is, it's coming up next, linear inequalities. All right, so region defined by inequalities. Let's going back to the lessons. You don't have a hand, you guys don't have a handout, but you can take a notes. But these guys can see it. You can open this OneNote to access this. It's on my Google Classroom. Can you open it up on a OneNote?
What's the page number?
Page number on the book, 170 to 180. Are you all good? Can you see that?
Yeah.
All right, so we're gonna going back to here. So Vishali, do you think that -2, -8 satisfy this region shaded? So how do you know? That's right. So Jess, so we're going to do algebraic checkup. So how are we going to do algebraic checkup? Y is, so my Y is -8, right? And then x minus 12 is -8 minus 12 is -20. -8 is greater than -20. Make sense? Okay, Shreya, not Shreya, Michelle, do you think 12 comma -10 on the shaded region?
No.
Pretty good. We can verify algebraically. And Shreya, it's 14 comma 2 is on the shaded region.
Yeah, it's on the line.
Yes, so on the line. So on the line mean it is no, because let's double check to verify. My Y is 2. My 14 minus 12 is 2. Is it 2 is greater than 2? Is 2 is greater than 2?
No.
My question is 2 is greater than 2. No, so it is no. How about -3 comma 4? -3 comma 4 ends on the line. Yes, so you can see that -3 comma 4 is here, -3 comma 4, -3 comma 4 is here. 6 comma of -14, sir. No, 0 comma -12. 0 comma -12. No. So let's see why not. So 0, x is 0, isn't it? Make sense? So y is -12. My x minus 12 is 0 minus 12 is -12. Is it -12 is greater than -12? No. So now we're going to going back here. We're talking about a linear inequality. In the graph of linear inequality, the line will separate the solution set for the non-solution is called the boundary line. So you have a boundary line. The solution set is the region. It's not just single point, it's an area. When the inequality is written as a strict, that means the solution set does not include the boundary line for example, x is greater than 2. When x is 2, it's included. So the dotted line say don't include that line. Don't include the line. And then the solid line may include the line. Are you guys following that? Include the line. So we're going to going back to some example here. The boundary is shown in the graph is y is equal to 2x minus 1. Write the inequality shown by the graph. So how we're going to be able to write the inequality shown by the graph? This is where the challenge is coming in. So what we're going to do is we're going to choose the point. Watch this. I'm going to choose a random point. So do we have a point -2 comma 2 on there? -2 comma 2 is there. Okay, can you guys do me a favor? So I will do that for you guys. You guys going to be write the inequality. So all I'm going to do is I'm going to substitute for y. What is my y? Y is 2, isn't it? What is my x? So 2 times x is -2 minus 1. What would I get? -4 minus 1. -4 minus 1 is -5. What do I know about a 2 and -5? 2 is greater than -5, isn't it? So the inequality here is going to be y is greater than 2x minus 1. What would I do? I will verify by choosing another point. Let me choose another point. So what point we're going to choose it? Let me choose -2 comma -1, isn't it? So y is -1. What is my x? 2 times -2 minus 1, -4 minus 1, -5. Is it -1 is greater than -5? Yes. You say no. Okay, can you guys do me a favor? Can you find me what equation represent the next inequality? You try time. Give me the equation that represent the inequality. Give me the inequality. I want inequalities. Let's see how would you guys write the inequality. So there are 1, 2, 3, 4 questions. You guys gonna do on the decimals. I'll be back. You guys gonna do that on the decimals? Use my technique. Use the technique I show you. Is that what you're learning at school?
Yeah.
Okay. Use my technique. That's disappeared for them. All right, so let's see what inequalities these guys get. I think my screen share, it's in my screen share stuff, or let me see. Are you seeing my screen?
No, not anymore.
Okay, so that means I need to. All right. All right. How about now?
No.
No.
Stop broadcasting. Stop. So why it's not doing share screen? Why is it? What's going on here? Why is showing my camera option? Screen. Photos, Microsoft SharePoint, URL, whiteboard, and I'm on my screen. All right, so screen. It's automatically go to photos. Yeah, what I'm gonna do. All right. I'm gonna restart this again.